Good evening to our lecturer, which is Dr. Muhammad Kir. My name is Muhammad Afiq Hakimi bin Saleh, and my matrix number is CD240067, and I am the group leader for group 13.
Hi everyone, I'm Divya, daughter of Ilangu. My metric number is CD240020.
My name is Muhammad Fitri bin Zabani. My metric number is CD240299.
Assalamualaikum warahmatullahi wabarakatuh. Saya Muhammad Karim Hafiz bin Kamal Azman, membuka matrik CD240006 daripada static section 9.
My name is Muhammad Ismail Razi bin Ishaq. My metric number is CD240102. I from section 9.
Introduction. Static is the branch of mechanics that deals with the forces acting on stationary bodies and their equilibrium. It's a key foundation of designing and analyzing stable structures in engineering such as building, bridges, and machines. Today we all explore how the principle of statics help ensure the safety and functionalities of this system. Let's begin by understanding the basic concept of statics. In engineering, we need to make sure that every structure or machine remains stable under the forces acting on it. But how we don't know whether a structure is safe? How do we calculate the forces acting different part of the system? This question by using Newtonian principle of analyzing equilibrium and forces on stationary bodies. In statics, objects are considered rigid bodies, meaning their shape doesn't change under the applied forces. Static assumes no movement or deformation of the body and focus on the forces and movement that must be in equilibrium of stability. The body is in static equilibrium when the summation of all the forces acting on the body equals to 0. The summation of all the movement top acting on the bodies equals to 0. In a 2D system, forces and movement are represented as vectors. To solve equilibrium equation, we decompose these vectors into the scalar component. Summation of forces in the x direction equals to 0. Summation of in the y direction equals to 0. Summation of movement about the z-axis equals to 0. 3-dimensional statics. In 3D, there are 6 equilibrium equations, 3 for forces and 3 for moments. Summation of forces in the x, y, and z direction equals to 0. Summation of the movement around the x, y, and z axis equals to 0. Static is essential for ensuring the safety and reliability of structure by ensuring all the forces and movements are in balance.
A static problem is one that requires determining the force and torque acting on an item in static equilibrium. Static equilibrium occurs when a body remains motionless and the sum of all force and torque moment acting on it equals 0. Solving such a difficult necessitates the use of engineering judgment, theoretical knowledge, and appropriate analytical approach to ensure the structure safety and stability, as well as to confirm that the equilibrium equation are properly certified.
Salam and good evening, sir. My name is Afiq Hakimi. So I am going to present about our project objective. So first thing first, we want to solve static engineering problem by applying the knowledge of physics, mathematics, engineering principle, and engineering mechanics. And secondly, we want to apply the fundamental of engineering mechanics to solve static engineering challenge and arrive at well-supported conclusion. And lastly, we want to successfully solve the static engineering challenge both alone and as a leader or member of various teams in multidisciplinary setting. Thank you.
As we go through the presentation, these ideas are applied in real-world engineering problems. Tower crane, ensuring foundation stability 2D. The foundation of a tower crane must be strong enough to support its weight and additional load. For example, a tower crane collapses with its foundation isn't properly designed, such as with weak or improperly. Static is used to analyze the force acting on the crane and its foundation to ensure that the foundation can be support both crane weight and external load like wind. The second one, pedestrian bridge, analyzing thrust forces, 2D. Pedestrian bridge use trusses to distribute load and this must be analyzed for stability. For example, in a pedestrian bridge, forces act at the joint of trusses. Static help engineer calculate the forces at each joint and ensure the structure can be support pedestrian traffic safely even under heavy loads and environmental conditions like wind or snow. The third one, scaffolding. Scaffolding must support workers and material without risk of collapse. For example, in a construction, scaffolding provides access to elevated areas. Static is used to calculate the forces acting on the scaffolding, ensuring its reinforced to prevent structural failure and protect workers. Here to analyze the forces acting the individual scaffolding components. Engineers calculate the distribution of these forces using equilibrium equation Fx equals to 0, summation of Fy equals to 0, and design the scaffolding withstand the load without failure. Traffic light pole, wind and weight stability. Traffic light pole must remain stable under wind load and the weight of the light. For example, static help calculate the reaction forces at the base of a traffic light pole, ensuring that it remains upright and secure under the both weight of the light and wind forces. Engineers calculate the vertical forces, weight of the pole and lights, and horizontal forces, wind, as well as the movement about the x and xyz axis equals to 0. This equilibrium equation ensures that the forces balance in the direction, preventing the pole from tipping over. Finally, the fifth one, crane boom, balancing forces during lifting. A crane boom must remain stable while lifting heavy load. For example, static is used to analyze the forces acting on the crane boom, ensuring that the support reaction at key point of preventing tipping while lifting large load.
So today I will talk about mathematical modeling for this project. So the question is, a worker use a vertical force while forcing to lift sand using a wheelbarrow. Given that the load of sand weighed at 45 kg, so how much effort is required to lift the weight vertically? Let's think together how much force should be used to lift the sand for one worker. So the method that we use in this problem is equilibrium of rigid body. So we can calculate that the total force need for the worker to lift the wheelbarrow by adding together all the force acting in both directions and the moment on it. So we refer to use this equilibrium of rigid body method because it is easier for us to solve this problem. Next, I will talk about step by step how to solve this problem. So first, we need to define the problem. So we need to clearly define the system of the particle and understand the external force acting on it. So the second step is to draw an free body diagram, which is FBD. We need to draw an accurate free body diagram based on the equation. Also, we need to label each force and its direction. So the third step is to resolve the force. We need to resolve all external force into the respective component along the x and y axis. The next step is to applying the equilibrium. So we need to write an equation based on the equation for the force in the chosen coordinate system, which is Fy, Fx, and the moment. We also need to label the positive and negative direction, whether it's clockwise or anti-clockwise. Next, we need to identify the unknown. Identify any unknown force in the problem and clearly define their direction. before we do the calculation. The next step is write the equation. Using the equilibrium condition and the resolved force, we must need to write an equation and expressing the force in sum and it's as a zero. Second, for this slide is to solve the unknowns. Solve the system of equation for the unknown force and watch out with the units and coordinates. So for the each step, we need to check a unit and the sign. Verify that the unit are consistent through the calculation, and we must need to recheck the sign and units always to make sure we get an accurate answer. So next, we need to interpret the result. Check the solution and the result. Ensure that the magnitude and the direction make sense in the context of the problem. Example, the tension is always in positive. If next, make an conclusion. Ensure that the particle is in static equilibrium if it is at zero total force. And the final step to recheck the equality. Make sure the result make physical sense. For example, the force must be in positive.
Hello, so nextly I will be present about the result and analysis. So from our question, they are asking for a magnitude of the force on each handle. Hello, so nextly I will be present about the result and analysis. So from our question, they are asking for a magnitude of the force on each handle. So first thing first, what we have to do as usual, we have to draw the FBD, which is the free body diagram, and then we have to sort each point to its own compartment, and then we have to generate equation of equilibrium, which is I already write it in the paper. As you can see, I generate the summation of force in X, which is we can find out the Bx, which is equals to 0, and then when I'm trying to generate the summation of force in Y, as you can see there are two unknown, and that's the reason why that's why I generate the summation of moment. And from this third equation, I can find Ay, which is 264.87 Newton, and I substitute it to the first equation, the summation of force in Y. And lastly, as you can see, I can find the force on each handle, which is By, which is 88.29 Newton. I think that's all from my part. Thank you.
Today I want to talk about my discussion about my project. Firstly, challenges in wheelbarrow force analysis. Analyzing the force acting on a wheelbarrow is a complex due to factors such as load, weight, the position of the counter of the center of gravity, and the angle of applied force. Even small error in measurement can lead to incorrect result. Additionally, wheelbarrow often experience dynamic force caused by motion such as acceleration, deceleration, or uneven surface, which require combining static and dynamic principles for accurate analysis. Second, design improvement for wheelbarrow. Improving wheelbarrow design focus on SSJ, usability, and efficiency. Adjustable load position can optimize the center of gravity, reducing user effort, improving stability. Using lightweight yet durable material like advanced composite decrease the overall weight without sacrificing strength, and integrating force sensor allow real-time monitoring of load distribution, enabling better safety, performance and user experience. Lastly, application of static principle. Static principles are widely used to ensure structural stability in bridges, building and crane by balancing external force and moment. They also contribute to the optimal design and load carrying device like hand truck, cart and stretcher, reducing effort and increasing efficiency. Furthermore, static principle in ergonomic product design extend the functionality and comfort for everyday items such as wheel, luggage and adjustable furniture, meeting the diverse user need. That's all. Thank you.
From this group work, we found that the importance of static in daily life. Various types of things require equilibrium. For example, crane, traffic light and so on. To meet the question in this group work, we choose a man pushing a wheelbarrow. This is because there are several things involved in our title, namely equilibrium of rigid bodies. For a more detailed explanation, we choose the real life situation because there are several things that meet the equilibrium of rigid bodies. Among them is that there is a force applied to a man pushing the wheelbarrow. Then, we need to use several formulas to identify the magnitude of the force each handle. Here, we use the formula of sum of Fx is equal to 0. Also, the sum of Fy is equal to 0. We also use moment to find the value of Ay. Do not forget, the sum of MB is equal to 0. As a result, using the correct formula, we can solve the question. This has proven to us that the importance of equilibrium of rigid bodies to real life situation. Okay, now we go to the recommendation. The recommendation we can give is that we need to identify the requirement of the question so that we don't do the useless things. Formula are the main things to solve the problem. So, we need to make sure that our formula selection is correct and accurate so that there are no error in calculation. In real life situation, if the calculation is wrong in making something, it makes the result unbalanced and will cause trouble for other parties. So, equilibrium of rigid body is very important in real life situation.